Welcome to Concept Based. I'm John Hepworth, and today we're doing a Year 11 advanced question. It's from the trigonometry and measures of angles section in your syllabus, specifically in the part that says trigonometry with angles of any magnitude. And the outcome is apply the sine rule, cosine rule, and formula for the area of a triangle to solve problems where angles are measured in degrees and degrees in minutes. So not radians. So make sure with your calculator you are set to degrees to do these calculations, because obviously what will come out will be completely wrong if it is set in radians mode. Just on that, in the HSC, some students use two calculators and they write on one of them that it's, well, they don't write it, sorry. And they have one of them that's a radian mode and one of them degree mode. Don't write any calculator. We don't want to have any notes in the HSC that you get pulled up on. All right, so this question here, this one actually applies two rules. We have an area formula and we need to use the sine rule to calculate that. How do I know that and how did I work that out? Well, first of all, with the question asking for the formula for the area, I'm just going to write the formula for the area down. I'm going to bang on again about the need for you to remember some formulas. Sure, there's formulas on the formula sheet, but this is a basic one. It's like a half AB, just like all the triangles you've been doing forever up until year 10. And then this one has an angle in it, so it just has sine C. Very, very small extension from the triangle area formula. So I would recommend recalling this one. Now, if we go and apply this formula to the image that we have here, we do have two sides already. So we've got this 12 here and we've got this 18. So we really just need to have the angle in between those two sides, which is this one here. And we could fill in our formula for a half AB sine C. But we don't have that angle. Now, we can't immediately go and find that angle from the sine rule, because if we were to try and do that, we'd be trying to use a side that's unknown also over here. So we can't do it directly, but we can do it indirectly, because if we find two angles inside a triangle, then we're going to know the third angle in a triangle, because we can just use the idea of the angle sum of a triangle. So what I'm going to do first of all is I'm going to find this angle. Now, remember some of the videos before we talked about the sine rule have an ambiguous case, whether it's an acute angle or an obtuse angle. This is one of those situations. You really need to be looking at the image and going, okay, I'm finding an obtuse angle to know what you're doing here. So let's go and apply the sine rule. So we're going to have sine B is the thing we're looking for here over the B side is equal to sine A is the thing that we've got, and we've got an A side already. So let's go and fill in the details that we have. So sine B that we're looking for over the B side, which is 18 centimeters, equals sine A, which was sine 32 degrees, not radians, sine 32 degrees over the A side, which is 12. And at this point, you can get out your calculator and find out what B is. I'm using a Casio FX82AU Plus, not a sponsored video. If Casio want to reach out, then certainly feel free. I've been using Casios forever. My HSC back in 1996, I was using a Casio. And this Casio I've been using for so long that it has no writing on the buttons anymore. They're just all blank because I've used it a fair bit. I don't know how many years I've had this one. So, going and typing in sine 32, always close the brackets on your sine function to make sure that you're doing it correctly. Divided by 12 times 18 gives me some decimal, in which case I do inverse sine of that decimal, and I get that B equals 52.64 degrees, right? Wrong. Not right. Because 52 degrees is an acute angle. And this is an obtuse angle. So this is like, it's actually not an ambiguous case because I can look at the picture and go, that's obtuse. So I don't want 52.64. That's the primary angle. In our unit circle, ASTC, we get AS in the top two quadrants. We've found the primary angle over here. So using part of the butterfly, we're going to be looking for the angle over here by doing 180 minus it. So I'll do 180 minus the angle that I had there, and I get B actually equals 127.36 degrees. What I'm going to do is store that in my calculator, shift store A, so that when I do calculations with that angle in the future, I can just use the exact one. I don't want to round off in the middle of a calculation and then apply another calculation and then round off again, because I can cause a rounding error. Okay, so we've found this angle, 127.36, but that's not the angle we're really after. Remember, because this 127.36 degrees is here, and for our half AB sine C calculation, we actually needed this angle here. So we need to go back now and do 180 degrees minus the angle minus our 32 over here. So minus 32. And we get that B is equal to 20.64 degrees. All right, great. Now I'm going to store that one, shift store A. So I've now got the angle that I actually wanted. And I'm going to go back to the formula that I was originally trying to fill in and go for it again. So I'm trying to do area equals a half AB sine C. Now, this is C that I found in the end. Right, so I'm going to have a half. Now, A and B are the two side lengths, 12 and 18. Doesn't matter which order, because with multiplication, you can multiply in any order, times sine of this 20.64 degree angle that we had, and whack that in the calculator. Times 12 times 18 times sine, recall A, and I get 38.07. It's actually 38.08 if I round up. But this question probably is going to ask it to the nearest square centimeter if it was in the HSC. So the answer is probably just going to be rounded to 38 square centimeters. And there we have it. Now, if your calculator would have been in radians, your answer would not even be close, right? It's just going to be completely wrong. If you would have put in the acute angle here, not the obtuse angle, also, it's going to be completely wrong. Now, even though the answer is completely wrong, the markers are going to know these cases of the incorrect answers. They're going to know the error that you made. So you would probably just lose 1 mark. 1 mark if you did it in radians, 1 mark if you did the acute angle, not the obtuse angle. And I think this is probably just a 2-mark question. The first one's the application of the sine rule. Pardon me, the next one's the application of the area rule. So I think it's really only a 2-marker. So you'd lose half your marks if you made either of those errors with the radians or using the acute angle. And there is probably the last question we're going to look at in this section of your syllabus. We will be moving on in future videos. But there are hundreds of these types of questions that you should be doing because they can appear in all different ways. The cosine rule obviously can apply, which we didn't use here. So just make sure you're doing enough practice that you are across your sine rule, your cosine rule, and your area formula.